This software is under active development, particularly its user interface. We are soliciting suggestions from people like you, the viewer of this video, and incorporating them into our design. That means that the interface that you see in this video may be subtly different than the version that you've downloaded. The overall design and function, however, will be the same. This is CSciBox's Graphical User Interface, or GUI. It's how you interact with the system and all of its parts, including importing and exporting data, running computations on it, for example with Bacon or Calib or Strata Counter, and plotting the results. The main part of the screen here is a spreadsheet-like representation of the data, which we call the grid. Above that are a bunch of buttons and widgets that will allow you to do stuff. This button allows you to select from among the records in CSciBox's database. It ships with three: a lake core, a marine core, and an ice core, but you can import your own. I'll come back to that. This button allows you to control what you see in the grid. I'll come back to that as well. This button allows you to run scientific workflows in the data, and this one allows you to plot the results. First, I'll explain the columns in the grid. Each row is the 14 CH for a particular depth in the core, derived from different kinds of material, which we can look at by expanding the grid. This is charcoal, wood, seeds, and so on and so forth. More on controlling what you see a little bit later. This column, the run, tells you what scientific workflow has been applied to the data. Here, the data were just brought in by a workflow that inputs them, so there's just data. There's nothing in the calibrated age column. We'll fill that in a sec. Ignore best age for now. We're going to call that something different. You can sort the grid, ascending or descending, on different columns by clicking in the header. CSciBox ships with a couple of scientific workflows, which you can run with this button. These are standard analyses that people like to do on sediment or ice cores. For example, you might want to run just simple Calib, you might want to do a reservoir age correction, you might want to do some interpolations, you might want to use Bacon, or you might want to be playing with an ice core. You can build your own workflow out of building blocks that ship with the software, or you can even plug in your own blocks of code. That too is another video. So I'm going to apply one of these scientific workflows to this core that I've got in my grid. And you see that there's now information in the calibrated age column. Let's do some plotting. This drop-down allows me to select which variable is on the independent axis. And this button lets me select what I'm going to plot on the dependent axis. And let's say I want to plot calibrated 14C age in a purple triangle icon. There they are. This button allows me to manipulate the plot in different ways. Maybe I want a legend and a grid. Maybe I don't want the legend, but I want to show the error bars and I want the font to be bigger. The points here are the means, the error bars are the standard deviation, but I can click on a point and get the actual distribution, like that. I can plot multiple things simply by checking off more boxes. So now what I'm doing is I'm plotting the raw and calibrated ages in different shape and color icons. Now, these are just age points. There's no interpolation. If you want to interpolate, you need to put that in the workflow or use a workflow that has it. Here is such a workflow. Now when I run that, a bunch of stuff happened. Among other things, there are now 2 different rows for each depth in the core. That's because we did 2 different things to the age at that depth. Now let me plot this. Now what I'm going to do here is plot the model age. That is the interpolation. And I'm also going to plot the points that it used to create that interpolation. By the way, I can also export plots in any number of formats. Now, an important use of an age model is to assign an age to a depth in the core for which you have no data. That wasn't the case with the Harding Lake core, but the Pacific Deep Water core data set that we have here has some depths where there's no data. If we want to build an age model and then use that age model to assign ages to those depths, here's how we do it. Instead of using a computation plan that just does a calibration, I would use a computation plan that does a calibration, then builds the interpolation, then assigns the ages using that model. Again, what happened here, the calib block calibrated the existing 14C ages. The interpolate block basically connected the dots. It drew a curve between those points. The assign block mapped the heights of that curve to all of the ages given in the grid. And the result is in the model age column, and you can see that here at 251 centimeters, there was no data, but now there's a model age because of the interpolation. And we can plot this. And there they are. The Pacific Deep Water Core is a marine core, so we really should be using a reservoir age correction. And we can do that using the marine calib computation plan, which does a reservoir age correction using data from the 14 chrono database, and then a calib style calibration. So if I run that, there it is. If CSciBox knows the latitude and longitude of the core, it will look it up directly. If it doesn't, it will ask for the latitude and longitude. I don't know where this core is, but I'm going to make something up. Click OK. Now what's going on here is CSciBox is looking up for the latitude and longitude that I entered. What's the nearest place in the 14 chrono database where there exists a reservoir age correction? I can accept that, in which case CSciBox will use whatever's in the database for this point, or I can reject it and enter my own numbers if I want. You can also run Bacon from inside CSciBox by using this workflow. Now we've got 3 different rows in the grid for each sample, and the data in this row came from just simple calib. This did a linear interpolation, and this did a Bacon interpolation. The grid can get pretty full pretty quickly because CSciBox's power lets you do lots of different analyses very quickly. And that's where those 2 right-hand panels come in. Those are metadata. Metadata is data about data. For example, what computation plan was used, with what parameter values for that run, what papers you should cite about the record or about the methods, things like that. And you can show or hide the details as you wish. You can also right-click on the run name if you want to change it. For example, if that's what Martin's group did, or analysis in Collins' thesis, if that would be more meaningful to you. This metadata stuff is critically important because it makes everything completely reproducible. And CSciBox's plotter lets me plot anything I want out of this busy grid, any set of columns from any set of runs, and export plots in any number of formats. Other videos in this sequence show you how to import and export data or build your own computation plan.